All right, thanks. Thanks for the introduction. Hear me? How about now? Yeah. All right. Thanks for the intro. So my name is Vijay. Today I'm gonna present this tool called NeuralSmith that we have built. We are still trying to frame it, but as of now, we're calling it AI ML Engineering Copilot. And the motivation is to basically empower domain experts. So for example, I'm a wireless researcher, actually, or a 5G, 6G researcher. So, but we do use AI, right? And at this point of time, who doesn't use AI, right? But we are not AI specialists, right? So the problem we faced, and it comes from our own experience, is that we have a lot of great data, but we don't really have ML team or the ML expertise to make something out of that data, right? But we are the domain expert. We are the one who understands each and every column, each and every row in that CSV file, or whatever that image data is, or whatever that time series data is. But if you want to wait on an ML team, then you obviously need an ML person or ML team who doesn't know the data, right? They're plain data analysts or the ML engineers. So there is a gap, right? So you have to wait, right? Or you have to learn it yourself, which what our students mostly do. And that also takes several weeks to months. Even an ML specialist would take several weeks to go through that hyperparameter tuning to build a good model. And many a times you don't even know whether your model is optimal or not, right? You might actually create a much bigger model than what was needed for that particular data set, right? So we said this is a very generic problem across all the domains, right? Can we solve this problem? Can we do something about it? So that's what kind of motivated us to look into this problem a little bit more closely. And then what we did is we basically built something called NeuralSmith, and the name comes from neural network plus blacksmith, right? So we are trying to mold or create or mold, the neural network in general, which is a representation of machine learning or deep neural network kind of stuff, to something which is usable and production grade, right? And our goal was to sort of cut down this manual engineering process that goes into the entire ML pipeline, all the way from data processing to, let's say, EDA, the exploratory data analysis that you have to do, all the way to ML design, like what kind of ML you want to use, all the way to hyperparameter tuning, ML engineering, all the way to training, and finally the inference or the testing, right? We wanted to bring that down to as much as possible. So ideally, in one instance, in minutes. So to make it very, very usable for domain people, right? They know the data, right? They can interact with you. They can tell you what they want to do. But if you ask them to write a code, then that's going to be a problem. So we wanted to make it a more natural language driven so that the domain experts can actually talk to the tool that, okay, this is the kind of data I have. This is what I'm trying to do. Can you do that for me, right? We wanted to make it local for two reasons. First, hosting on a cloud costs money, and I don't have funding to do that. And second, a lot of data are very sensitive, right? So you may not want to actually upload that data or give that data to somebody, right? So as long as it's on your own computer, you'll feel much safer to use it. So those were the two reasons. Second, I would say not zero exactly, but because you have to understand what's doing, right? So you have to have some knowledge, but you don't really need to understand everything. So I would say 0 to little ML expertise needed. And what you get is a production-ready output, okay? That's our goal, right? And this all happens within minutes. So that's the main value proposition here. So this is what our tool does. So we basically take input, right? So whether, let's say, whatever domain constraints that you have, whatever, let's say, label you're trying to predict or classify or train, for example, in wireless, is there a jammer in this room or not, right? yes or no. It's a very simple binary classification. And then obviously wherever your data is available, whether it's in a certain directory, in a certain format, you might want to point it to that, right? After that, what we do is we do the prep. We basically figure out what kind of data it is, whether it's tabular data, whether it's image data or something else. And then we take necessary step for those data, do the EDA if necessary, normalize, basically do the whole data processing. You can skip it if you want, but that's a feature that's available. And then finally, we build, or we try to build candidate models. And there we do a lot of stuff. We do neural architecture search. So we try to build the exact unit of machine learning that should work, all the way from your cost function to the number of hidden layers, to the biases, to the number of input, output. We also leverage LLMs to help us do the hyperparameter and the configuration a lot. And we also look at the state of the art that's available, which has been proven to work really well on those kind of data. So there's a lot of things going on. I don't want to get into the details because it's not fully open source yet, but it's free to use. And then the output would be the model that works really, really well. And we also give you the code. We also give you the model. We also tell you how exactly we trained, what kind of parameters we used. And then we also let you question back and forth on whatever you want, right? As of today, we support the images, any kind of images, tabular, regression, classification, time series, and the labeler. We are still working on the LLM fine-tuning and the RAG stuff. But these are already available. We have 3 modes, the fast plus. So here it's a very, very quick smoke kind of testing. So we basically run a few models so that you get a feel for it. But then if you want to do on a daily basis, then we have a fast mode where we actually do a balance between the kind of resources your computer has. If your computer has GPUs versus CPUs, then we can do more models. If you have very limited CPUs, then we try to use smaller models so that it works on your system. And the final is the exhaustive, where we do the everything possible. It takes a few tens of hours, not tens of hours, a couple of hours, but then the output you get is the best that's possible. And it's as easy as running a command like NeuralSmith, do this for me. On the agentic side, the conversation side, we have 3 levels. The first one is the default. I'm going to show you a couple of demos, you'll get an idea. So on the ask side, you basically communicate with NeuralSmith and tell it that this is what you're trying to do, this is what I want to do, and then NeuralSmith suggests you, okay, do this next, do that next. So you and NeuralSmith is kind of equally involved in many ways. You are not writing the code, but you are guiding NeuralSmith in every step, or NeuralSmith is guiding you in every step. The second level is assisted, which is an agentic mode where NeuralSmith does everything for you. It just asks for an approval. Okay, that do you agree with this, or do you have some feedback? And the final is fully autonomous. So there, as long as you fully trust NeuralSmith, it will do everything from reading the data all the way to generating the model on whatever it want to do, and gives you the result. Because we have a conversation agent involved, we have to have an LLM to understand that. And there you can use any API, any subscription that you have. You can use Google, Gemini, OpenAI, Anthropic, Claude, Olama, or bring your own model if you like. If you have some local hosted open models, you can use that too. We also support NeuralSmith as a skill or as an MCP server, so that your IDE, like say you are using Claude Code or you are using Cursor, right? You can simply install NeuralSmith as a skill, and then your Claude Code is actually acting as an ML scientist or an ML engineer. And this is basically the 3 lines of code you have to put there. Git clone that stuff, copy, and then do it. And then you will have the skill. And then Claude Code itself will call NeuralSmith to do the machine learning task for you. So here is some of the testing we did on ours at our end. So the table that you see is a few wireless data set that has been published in the literature. And there you can see we beat almost all of them. But the most important column, I would say, is the 4th column, the time. right? We do this in seconds and minutes, right? Compared to, these PhD students probably spending several weeks, if not months, right? We also tested this on MLE Benchlight, which is available as an open source. And there are like a bunch of data sets, like 14 or so, where people compete who builds the best model. And NeuralSmith was always within top 2% of the model. So here is one collaboration we did with WPI, Orchestra Polytechnic Institute. So this is an open RAN. This is one of my topics that I work on. And there the intuition was that given an intent, right, that let's say I want to have 200 megabits of data rate for 2 hours in this room, right, for 200 people, given that intent, can I reconfigure the network so that it's doable? So understanding the intent, you can use an LLM for sure, but it takes several hundreds of milliseconds. But running those configurations has to happen in tens of milliseconds, okay? So what we did, we said, okay, let us use foundational ML or foundational LLM as the orchestrator who can understand the intent, okay? So it tells us that, okay, network has to do certain thing, but whatever network does, let us do that through NeuralSmith so that it can happen in milliseconds, okay? So that's how we used a concept of dual brain. So let me explain. So basically here what we do is we let the LLM think, LLM understands the intent. I'll show you a little example. And then the ML engine, which is NeuralSmith in this case, it actually computes or builds model for those network tasks, let's say scheduling, for example, and so that it runs in sub 10 millisecond. So this was the idea there. So here, if you see my arrow, predict congestion and reserve 20% of PRBs for edge users, for example, right? So this intent is taken by this zero-touch agent or LLM orchestrator. It understands the intent, and then it basically does the data curation. They did not want labeling. They wanted to do it themselves, so we said, okay. So they did not use labeling feature of NeuralSmith. And then it gives that to NeuralSmith. And what NeuralSmith does, NeuralSmith builds a model automatically. So there is no human involved at this point, except this operator intent who gives the intent. Okay? It builds the model, it trains, it retrains everything, and then it gives back that model as an ONNX model so that it can be deployed as a network application automatically. And then we were able to see, so this is in English, that was in figure, it's the same thing. And this is the whole process there. So in a way, ideally there would be a network engineer, data scientist, software engineer, deployment engineer, all of them is being done together with this dual brain architecture with NeuralSmith in the loop and the foundation ML in the loop. So with that, we were able to get this orchestration latency, which is the LLM, in 384 milliseconds, and the inference latency with less than a millisecond. Because NeuralSmith was given those constraints, and it was able to build a model which will run in less than a millisecond. And the accuracy we got was pretty good, 97.7% accuracy. And this is submitted as a paper as of today. And we're going to demonstrate in a couple of months. All right, so now to the demos. Okay, so that was all the background. So the first one, here I'm going to show you NeuralSmith as a Visual Studio Code extension. Actually, I can show you live. Let me see. I have a recording just in case. But let me see. Okay, you see this, right? All right, do you see my, yeah. So this is the NeuralSmith extension within VS Code. So here, as you can see, we have different widgets for image, tabular, and others. So here, for example, you want to ask something, I don't know, hi there, right? Right, so hi, I'm NeuralSmith. Now you can say anything like, okay, I have some tabular data set. Can you help me build a ML classifier? So it says something, okay? So it says, okay, go start the wizard. In this case, if I already said that I have a tabular, so that's why it says, okay, go check the tabular wizard and then start the wizard and do whatever it says to do, right? So if you go to the tabular wizard, it says start a new project. So you can go to the project and then it says browse the CSV file. I should have some data set. Okay. So this is a recent paper we did, so okay. So you can see the data set, it gives you what it is. So in this case, I think our column was labeled. It was a radar data set. So basically the data set had was collected in our lab where we had 5G communication going on. And then we had this federal radar. I mean, it was not a real radar. We basically had a little device acting as a radar. So we basically collected data under different conditions where radar is active or not. And our problem was, can we detect when the radar is available or not? So now in this case, I'm doing exploratory data analysis. It sees and it says, okay, and looks like I did not have some of the packages. So it was going to install those packages. So you don't have to do, so dependency is not a problem. NeuralSmith does all that on your behalf, looking at your computer system configuration. So here it seems like I have no missing values, no feature is recommended to be removed or anything. So as long as you're happy with that, if you're not happy with that, you can always communicate. Okay, like, I don't know, remove some feature if you like. So it can do that again. And then you can choose the model that you want. So in this case, I'm just gonna do fast++, given the limited time we have. So fast++ is really fast. So we will see that within just a few seconds or a few minutes, it's already done. So the training, oh no, it's still going on. Okay. So as you can see, right, I got 99.67% accuracy, right? And then you can basically, it's all saved somewhere here. So you can go check the models and you can get a lot more information, okay? So this is, so this is the first one available as a VS Code extension. Okay, and this, as you can see, is applicable or usable by any domain expert, right? So natural language based, right? The second one is based on the terminal. So if you are a developer who works with terminals, I can maybe also show you a live demo. So here we have two modes. One is the agent mode, where NeuralSmith seeks approval on every step it does. And we have an agent plus mode or agent plus mode, which is fully autonomous. So in this case, maybe I can show you live. Just give me a second. Oh, I need to open terminal. Okay. All right. Okay. So, and by the way, the manual is all available on www.neuralsmith.com. So you can follow the manual. I obviously know this because we have helped build this. So as you can see, this is on a fully agentic mode. And here I have provided a Gemma API. So it should be working. Sometimes Gemma is funny. It's free, right? So sometimes it doesn't work, but hopefully it works now. So let's see. Let's make a tabular classifier. And then I can maybe provide the same data set. Let's see if it works. Should work. Okay, so as you can see, it gives me some like different fields in there. It's inspecting right now. So, I mean, obviously training and all that takes time. So we might, but it should be fast given that the earlier was so fast. So it looks like it's doing the EDA. As you can see, no missing values. Okay, so it looks like it says validation successful. The data set is ready. Would you like to save the training results? output directory. So let's give some output directory. Let's say if I have, let's say this directory here. Okay, so it's running. Okay. Okay, so see, so it chose exhaustive by itself, right? You didn't, so because it's a fully agentic mode, it decided what you want to do, okay? If you ran it in a agent mode, then you would have the option to choose fast plus plus or fast or, exhaustive, right? So here it decided to choose exhaustive for some reason. And for some reason, it chose 11 candidate models, and we are able to get training is complete about here, right? So for different models, we got different kind of score, and looks like it's a pretty easy data set. So almost everybody is giving me really good results. And then it saved everything. If you want to look at that, let's look at that. So this one over here, right? So if you see here, right, it has many different things.
Not seeing that on the screen.
So, oh. All right. So if you see here, right, so over here, okay, I have to, because it open new pages all the time. So maybe I'll not show too many things. So here, as you can see, this training summary report, it has all the reports over here, right? And then if you go back to that folder, it will have the exact best model over here. Over here. So over here, it saved the best model, but it also gave you the other candidate if you wanna use others for whatever reasons, okay? All right, so that's the agentic mode or the terminal mode, the CLI mode, okay? All right, so I'm gonna move to the next one. Now this one I will show with cursor. I don't have cursor on my computer, so I cannot show you live. But this one is, this is for image data set, okay? I just wanted to show you different modes, right? So far I was showing you tabular data set. Now I'm showing you the image data set. So this image data set will be done through scale within cursor. So here, that's where the GitHub repository is. So that's why you needed those 3 commands, okay? Obviously, on the demo, we have already installed on the cloud. Sorry, on the cursor. So if you see on the top, so this is the data set we have. This is a jammer presence or absence data set. This is, again, a wireless data set. So here on the top, if you see, I basically say, okay, make a classifier for this data set. The font is small, but I hope you are able to see. So now basically you will, so if you see, it calls NeuralSmith at some point as a scale, but you will not notice the difference because it seems like as if you're working with cursor. Okay? Make sense? With the WPI, we actually provided API. So that was an MCP, NeuralSmith available as an MCP. But here it's literally available within cursor. So you will not even know until and unless you read those texts that cursor gives you. So that's what's going on. Maybe I can make it bigger. Let me see. All right. I hope this is better. Oh. All right. So I hope this is visible. So here, if you see get image classification wizard, right? So that's the NeuralSmith function that we had. the image classification wizard. We had 3 wizards, if you remember: tabular, regression, classifier. We also have time series and the image. So that's what it called. Okay? So this is all happening within Cursor. And then because we also look at what kind of compute resources you have, do you have GPU or not? Do you have CPUs? What do you have? So we looked at that and see the QDI is specifically for GPUs. So now at this point, it's basically doing the pre-processing, right? And this is again calling the EDA functionality that we have within NeuralSmith. And then it figured out that, okay, NeuralSmith would ignore this because there is already a split of test and train. So in that case, you are not using that suggested recommended action in this case. And after some point, going through all that step, now you're training the classifier within NeuralSmith, right? So with NeuralSmith, if you, maybe I can stop and so. So here, right here, if you see, right, so train this data set classifier with NeuralSmith, right? So until and unless you're paying attention to the comment or the reasoning that that Cursor provides you, you will not even notice that if it's using NeuralSmith or if it's trying to do on its own. So here, as you can see, now it's training. So after some point, we'll get a trained model, and then it will test and give you some accuracy. Okay? So you can use it as a skill within your own IDE. Okay? And lastly, this is my last demo here. This is for a time series data set. And this is also with Cursor. Okay, and in this case, I'm not showing how to install because it's already installed. And here, this is a data set we found online from Italy Power data set. And then here, just to have a quick demo, we just run fast++, and we got about 80, 85, whatever accuracy. Like I said, fast++ is more of a quick smoke test. It does work a lot of times if the data set is really easy, but exhaustive will always work, but it will take some time. Okay? So in this case, yeah, as you can see, it's already out there. And the test accuracy is 0.8008. And the model it used is Moment. So it for some reason, chose a time series foundational model. Okay? All right. So to conclude, this ML engineering workflow that we have, as you can see, we can build models extremely, extremely quickly, right? And it works across different domains because all those domains have certain data type, whether it's tabular, classification or a regression, or is some kind of image or some kind of time series, right? So it does work. Please give it a shot, right? And as I mentioned, it's free. The VS Code is in beta phase. We are still going through some iterations, but the CLI, the agent and the agent plus, and the skill, they're fully matured, okay? So give it a shot, and if you have any question, happy to take it. Thank you.
Any question?
For the CLI mode, when you type in, let's make an
Like a classifier, yeah.
Yeah, then the next thing you just copy and paste the.
Oh, you can say anything you like. If it doesn't understand, it will ask you question to clarify. Yeah, it's literally like a chat GPT going on.
But it does know automatically that's the directory that you pass.
No, you have to provide the directory. So what I did, I basically, right, put the directory there.
But okay, so my question is, does it know is that's the directory that you put right next to the first?
Yeah.
Thing is the directory to the data set, or
Yeah.
To be that way, or does it?
So if you don't provide, it will ask you to provide the directory. Like for example, for saving the model, I did not provide the directory. If you remember, then it said, "Can you provide me the output directory?" Right? So if you don't provide enough information, it will ask you to provide. Yeah, but because I ran it so many times, I just provided. And by the way, if you again. So we have worked really hard to make it, the wiki to be very, very nice. So if you go in there, it's very nicely put in there, okay? So we have the Copilot agentic mode, the one I showed you, the CLI. The skill, we haven't added it yet, but every other information is there. The skill we will add very quickly. Okay. All right. Yes.
So you were showing you had a frontier model as sort of the interpreter in the front end, and then it calls NeuralSmith that's running local models. Is it pre-configured to certain local models, or can you use plug and play whatever you want?
No, so we do a lot of things. We build models, okay, using neural architecture search techniques from that field or subfield of AI. We also look at frontier models. We also look at state-of-the-art models, okay? So we do a lot of things there, especially in the exhaustive mode. Yeah.
So it sets it up itself.
Yes.
So it will download.
Yeah, it will create model, it will train. Yeah, it does everything on its own. Yeah, if you're not happy, like you say, okay, don't use that, then you can tell that through the chat, and then it will skip that.
Have you seen it start to fail at certain model types? I mean, like if you have like a 4 billion parameter model, is it going to be able to work with?
Because we just use it as a conversation, it works. Yeah, because we are not really doing any complex tasks. This is just the natural interaction agent, right? So any model largely works. Yeah.
Any other question? If not, let's think about a speaker one more time.
All right. Thank you.
And there should be coffee now. So if you want to take a coffee break, go for it. Yeah, there you go.
Thank you very much.
How long do you want to do? Like 10 minutes?
No.
Oh, sorry. Yeah.
I'm just 20 minutes. I mean, that's about it.
No, I mean the break right now.
Oh, yeah, 20 minutes, yeah.
Yeah. 15 minutes.
Yeah, I'm sorry to take 15 and then, yeah.
Okay, sounds good. Okay, for people online, we will start again at 3:15.